So in this tutorial we're going to look at bounds, that's upper bounds and lower bounds, and also how we use them to create an error interval. And the key phrase to remember here is half up, half down, and that should sort out most of your problems. Right, now let's look at the questions. First question, 1 part A. A number is 3.7, correct to two significant figures. And we're asked simply to write down the upper bound for this number. So what we need to do is half up. Okay, now actually what does that mean? It means we add on half the degree of accuracy. So if you can't just see the answer, think about the degree of accuracy, which is the two significant figures, in this case the first decimal place, and we need a half of that. And now one decimal place is 0.1 and a half of that is 0.05. So the upper bound is going to be 3.7 plus the 0.05, and you can see as we add that on to get 3.75 how I mean it's a half up. If you think about this as 7, this is sort of 7.5, or if you think about the first one as 70, that's 75. So I have really gone a half up. Now in the second one we're given the degree of accuracy as the nearest 5 miles. Okay, so we need a half of that. So a half of 5 is 2.5, and we're asked for the lower bound for the distance. So the lower bound here is the 35 minus the 2.5, which is 32.5 miles. And there we go. Let's have a look at a different sort of question. So question 2, we're asked for an error interval. Okay, and the error interval is for the number 2.94, correct to 2 decimal places. So again, we're going to look at this bit here, and that's 0.01, so we need a half of that. The second decimal place, 0.01, and a half of that is, keep a hand on the zeros here, 0.005. So the lower bound will be 2.94 minus 0.005, and the upper bound will be 2.94 plus 0.005. Very soon you'll be able to just say, ah yes, that's a half down, which is 2.935, and a half up, which is 2.945. And again, look, we've gone from 4 to 3.5 and 4 to 4.5. So that is a half down, a half up, or a half up, a half down. How do we turn it into an error interval? Well, we take the lower bound and the upper bound, like I have here and here, and we put inequality signs and a symbol in between. Now I haven't actually got a symbol for my number, so I will just call it x. I might just indicate that. Okay, so I need x, and it can be as low as 2.935, because that would round up to 2.94, and it can be almost 2.945. Obviously that would round up, which is why we have the strict inequality here, because it can't actually be that. So with confidence, a half down, a half up, as long as I get my inequality signs correct. And finally, just a slightly different sort of question, okay, which may catch you out if you haven't seen it before. So John is doing a calculation, and he truncates his answer. Rather than rounding it, he just cuts off the decimal places. Okay, and he writes down his answer as 8, which means his answer is in fact 8 point something. Okay, I don't know what that something is. And we're asked to write down an error interval for his answer. Well, it could be anything bigger than 8, but not as big as 9. So let's write down answer and write down exactly what we've just said. So it's anything bigger than, or in fact equal to 8, but less than 9. It can't be 9, it could be 8.99, 8.999999, but not 9. And so we've got something that looks very like our normal error interval, as in the question above, but we've got to it by a slightly different way. So that's just one to be aware of. All I've done is followed the statement in the question.